All right, guys, first for this warm-up, we are going to decide what is the domain and the range of this graph. Take a second, check your answer, and then hit play, and I will let you know the answer. The answer to this question, because it is continuous, and you know continuous graphs are always less than or equal to because they are continuous. They can have more than one. It's closed dots. So it would be less than or equal to, not just less than. Your answer should have been C. For the second one, what is the domain and range, and tell whether this is a function or not. We know we can eliminate B because that would be discrete, and it is a continuous graph. My x's, if you would lay this flat down on the x-axis, it goes all the way from 0 to 3. So 0 is less than or equal to x, which is less than or equal to 3. If I were to smash this up on the y-axis, smash, I would go all the way from 1 to 4. So 1 is less than or equal to y, which is less than or equal to 4. So and they were closed dots. So when I look, 1's less than or equal to x, less than or equal to 3. 1 is less than or equal to y, less than or equal to 4. Okay, that one looks not good because of my first x. C looks good. However, it is a function because it does pass the vertical line test. Okay, this one, is it a function? Well, the answer is yes, because each x maps to exactly one y value. All right, today what we're going to do is we are going to be writing functions. But first, let's look and see if this table is a function. I like to, whenever I'm doing a table, I like to make it a mapping. So in our x's, we have 6, 8, and 10. In our y's, we have 5, 11, 17, and 19, if I put them in order. 6 maps to 17. 8 maps to 11, but 8 also maps to 19. Right away, right here, x maps to 2 values. So no, it is not a function. So today we're going to be writing functions from tables and from ordered pairs. So your target is, I can write a function. Couple of things we need to do. The first directions say determine a relationship and write an equation. So I want to ask myself, how do I get from x to y? So ask, how do I get from x to y? And I want it to be the same for all. So how do I get from 1 to -2? How do I get from 1 to -2? Well, I could do 1 minus 3. Let's see if that works here. How do I get from 2 to -1? Oh, minus 3. 3 to 0, minus 3. 4 to 1, minus 3. I had to subtract all of them. So how did I get from x to y? I subtracted 3. And right here is where I get my equation. I know that y came from, wherever you say came from, that's your equal sign, x minus 3, and that's my equation. We could plug anything in. Now with ordered pairs, I think sometimes it's easier to see it as a table, but let's just ask ourselves, this is my x, this is my y, this is my x, this is my y, this is my x, this is my y, this is my x, this is my y. How do I get from 1 to 3 the same way I get from 2 to 6, same way from 3 to 9, the same way from 4 to 12. Oh, times 3, times 3, times 3, and times 3. So I know, how do I get from x to y? Y equaled 3 times x. And again, always put your coefficient first. Now we're going to have two definitions, an independent variable and a dependent variable. What your independent variable is it sounds very much like the input, which we know is x. So it's what you can pick. It's independent. Key thing, you pick. You make the decision. The dependent is the output or the why. It's the result. Remember the blender, it's what comes out. So I always ask myself, blank depends on blank. And what you have here, what you say first, is your dependent variable. Always ask yourself that sentence. I always write it down. For example, if I have y equals 4x plus 1, my x is my independent, and my y is my dependent variables. So let's take some examples. Identify the independent and dependent variable in the situation. Here's our situation. It says ice cream sales increase when temperature changes. So the first thing you want to ask are, what are the two things that are changing? What are our two variables? We know ice cream sales change, and also the temperature changes. So would you say blank depends on blank? Would you say that ice cream sales depend on the temperature, or would you say that the temperature depends on the ice cream sales? I would definitely say this first one. So we know that ice cream sales is my dependent variable. I always do that one first. So this one is ice cream sales, because if it's colder, you're not going to sell as much ice cream. The ice cream sales, they absolutely depend on the temperature. Think a hot day, it's a lot more crowded. This one, Giant Eagle charges $8.50 per person at a catered event. So what are the two things that change? Well, their amount that they charge per person is not going to change, but I bet you the number of people changes at the event, but then also your total cost. So would we say that your total cost depends on the people, or that the people depend on the total cost? I think the cost depends on the people, because if you have less people, you're going to have a less cost. So total cost would be your dependent, your total cost, and your independent is your number of people. Now I want to take a second. We'll come back to function notation in 1 minute. But first, if I were writing an equation, my independent is my x, my dependent is my y. You always want it to be total equals. So my y equals my total cost equals the $8.50 times x, or the number of people. Now, this function notation, it's really just a fancy way. My dependent variable is a function of the independent variable. So basically, my dependent variable is y equals a function of, we're going to say it as f of, the independent variable is x. All this means, instead of writing y, write f of x, g of x, h of x. All this means is all those things. Then you know it's a function. You know two things about it. What two things do you know? You know that number one, that it passes the vertical line test. You also know that every x has only one y. You know so much when something's in function notation. So if I go back to the Giant Eagle equation, instead of writing y equals 850x, this is a function, so I would say f of x equals 850x. And again, the only thing that changed is instead of writing y, we wrote f of x. It's the same thing. So let's take a look at example 2. Suppose your lifeguarding job pays you $8.85 per hour. I want you to write an equation using x for hours and y for money that would model this situation. So first, hit pause and try this on your own. So we know, hopefully you wrote x equals the hours you labeled, and y equals the total money. So you knew that y, your total money, is $8.85 per hour. So for every hour, so you multiply times h or x. I'm actually going to, instead of writing x, I'm going to call it h for hours. So then function notation, instead of writing f of x, since I didn't use x, I used h, I'd use f of h equals 8.85h. If you did write it as y equals 8.85x, you'd say f of x equals $8.85 times x. So all you did was you replaced the notation. Instead of y, you wrote f of x. So on the back, we have 3 equations. I just want all 3 in function notation. Instead of writing y equals 3x, all it is f of x equals 3x. Instead of y equals, the only thing that's changing are your y's. You'd write f of x equals 2x plus 1. Instead of writing y equals 5x, function notation, f of x equals 5x. You know that each one of these passed the VLT, and every x maps to one y. I always think about it like a function machine. You put something in. So if I look at f of x equals 3x. I'm going to put something into my machine. I'm going to let x equal 5. So I'm going to go over here and put my x in. So I'm going to put it in here and put it in here because x is 5. It's going in to my rule. So I have f of 5 equals 3 times 5. So my rule over here would be f of 5 equals 3 times 5. Equals 3 times 5. And all this guy's saying, it's like he's talking to you. You're not solving for something. All this is saying, it is saying what is y when x is 5. You know it's a function. You know you will only get one result. So let's go ahead and do it. It's doing a rule. So we get 15. So f of 5 equals 15. Out came a 15. So the way that you would write it, it's an ordered pair. You know that when x was 5, y was 15. You didn't do anything over here. All it asks is, what is y when x is 15? So here it's saying, what is y when x is 5? Oh, the right-hand side is answering. It's saying it's 15, and you're good to go. Let's do a couple of steps that make life easy. I'm going to evaluate g of x. Remember we said it could be a couple things. Equals 4x minus 10 when x equals 3. So the first thing you're going to do is write the function. We know that g of x equals 4x minus 10. The second thing you're going to do is substitute 3 in for all x. So you'll plug it in here, you'll plug it in here. So you have g of 3 equals 4 times 3 plus minus your 10. Last but not least, you simplify. So you have g of 3. Remember, this side does not change. G of 3 equals, do your 4 times 3 is 12 minus 10. G of 3 equals 2. And I'm gonna add a fourth one, and I'm gonna say write the ordered